Hello, Senior 2. Lesson 2 in Chapter 2 is talking about trends and periodicity of properties in the modern periodic table. Look here, we're gonna study the graduation of the properties of the representative elements in the modern periodic table. We have 7 properties to study. Number 1, the atomic radius. 2, ionization potential or ionization energy. Number 3, electron affinity. Number 4, electronegativity. Number 5, metallic and non-metallic property. 6, acidic and basic property. And at the end, we have oxidation numbers. Now, we're going to talk about the first property, the atomic radius. Look, here you have to study first the concept of the atomic radius and the ionic radius and how to calculate them first, then the graduation. Look, it's wrong to define the atomic radius as a distance between the nucleus and the furthest electron, because according to Schrödinger, we cannot determine the position of the electron. We have electron clouds and orbitals. So, it's better to describe it as the following. In case of covalent molecules of elements, which consists of similar atoms, here we can determine, as you can see, the bond length of the covalent bond of these two bonded atoms. So, covalent bond length, it's estimated by the distance between the centers of the two nuclei of two bonded atoms, similar atoms. So here, we can get the radius of just one of them, as the atomic radius here will be half the distance between the center of two similar atoms in a diatomic molecule. So we can get the atomic radius here by dividing the bond length by 2. Here we have an example. Look. The bond length in hydrogen molecule H2 0.6 angstrom. So automatically you can calculate the radius of hydrogen atom. 0.6 divided 2. Then the bond length in nitrogen molecule N2 1.4 angstrom. Also, we can calculate with the same method the radius of just one atom of nitrogen. It will be 1.4 divided 2 equals 0.7 angstrom. Then, the bond length in nitric oxide, the bond length between nitrogen and oxygen is 1.36. Now we can get the radius of oxygen. Look here, radius of oxygen equals the bond length between nitrogen and oxygen minus the radius of nitrogen. We can get it. It's 0.66 angstrom. Now, calculate the bond length in oxygen molecule. Easy. The radius of oxygen times 2. And calculate the bond length between oxygen and hydrogen. Just radius of oxygen plus radius of hydrogen, as you can see here in the solution. Now, what's the ionic radius? Here, the bond length of the ionic bond is estimated as a distance between the centers of the nuclei of two bonded ions in the formula units of crystals. So the ionic bond length equals the summation of two ionic radii in the formula unit. If you have the bond length, ionic bond length, and the radius of one of the two ions, you can get the radius of the second ion.